everyone with a pleasant morning. And as a first for this year 2022, we have another task and another great learnings na naman. Make sure to tune in to Partido Mindoreños featuring Fieldwork exercise number 6, Trigonometric Leveling. Double-rotted differential leveling is a method of determining the difference in elevation between points by employing two routes simultaneously. Two turning points are established such that at each setup of the leveling instrument, two sets of independent backsides and foresides are taken. Employing double-rotted differential leveling provide a continuous check on the process of determining ground elevation while the work is in progress. The method is also useful when there is an urgent need to undertake differential leveling in a short period of time where no established benchmarks are available for checking results. This fieldwork exercise number 6 particularly aims for two objectives. First is to acquire and develop the skills of determining the vertical distance, the elevation and height, of a remote point by applying trigonometric and related analysis. And second, to develop the skills of reading vertical angles using theodolite or total station. This fieldwork will be needing the following instruments and accessories in order to proceed. First is theodolite, then leveling rod, markers such as chalk or marking pins, measuring tape, plumb bob, and range bow. The following steps should be followed carefully in order to proceed with the fieldwork. Step 1. Set up the theodolite at a convenient location and call it point A where the leveling rod and the remote point are visible. Step 2. Using the telescope, take sight at the topmost remote point, then read the vertical angle and record as alpha on Table 5 Trigonometric Leveling. Step 3. Take another sight for the second trial. This is done to determine the precision of the observations. Step 4. Calculate the mean of the two vertical angles or the angle of elevation, which is not the zenith angle of the specified point from the first station. Step 5. Set the leveling staff or rod vertically near the base of the remote point and take the level foresight, the horizontal line or zero vertical angle on the rod to determine the height of the instrument. Step 6. Transfer the instrument level or the theodolite towards the location of the remote point and designate it as Station B. Then measure its distance by taping from its initial position, the Station A, and record this as distance AB. Step 7. After centering the bubble of the instrument level, sight at the same topmost remote point or sighted before, twice using the telescope and record as beta on Table 5 Trigonometric Leveling. After recording these two observations of vertical angle, calculate the mean. Step 8. Level the telescope while at B and get the height of the instrument by sighting the same leveling rod near the base of the remote point. Step 9. Analyze and see the figure that follows. The right triangles formed to determine the height of the remote point, and this fieldwork will not consider the effects of combined correction of Earth's curvature and refraction. Analysis of the figure that follows. Number 1. Determine the difference in elevation between two instrument setups. Number 2. consider triangle B prime EF, then solve for the distance x using the tangent function. Number 3. Determine the sum of distance AB and distance x for the analysis of the oblique triangle A prime FB. Number 4. Consider triangle A prime FD and use sine law to determine the distance FD. Number 5. Consider triangle FDG and determine the height of the remote point DG. And that's it for fieldwork exercise number 6, trigonometric leveling. We are hoping that you have learned well from this presentation, and now we are bidding you a great day. Adios!